Okay, hi everybody. I wanted to just kind of briefly kind of narrate and go over some of the questions or all the questions from the Unit 7 angles and angle measurement quiz practice. So I have them down here. I actually went through them and it kind of worked them out, and then I realized it didn't record. So I'm going to kind of cover what I did here, but I'll make these solutions available for everybody to see. The first one wanted me to describe angle TAG. So what I did was I found points T, A, and G in my figure. Then what I did was I drew a 90-degree angle, a right angle, so I have something to compare it to. Because I know that a right angle is exactly 90 degrees, and I know that TAG would be less than 90 degrees. So if it's not 90, it can't be a right angle. And if it's less than 90, it can't be obtuse, because obtuse is greater than 90. And it can't be a straight angle because a straight angle would be a straight line. And a straight line is exactly 180 degrees. So it has to be acute. So when you get to this one, you want to look for acute because this angle is an acute angle because it's less than 90. The second one was asking us to find the measure of the smaller angle. So if you look at the hands of the clock, um, these two rays share an endpoint and they create an angle. And they actually create a 90-degree angle here. So this right here is 90 degrees. And if you think about a circle, a circle has 360 degrees, right? So if you take 360 and you subtract 90, what are we left with? 0, borrow a group of 100, give that to the tens. 16 take away 9 is 7, 2 minus 0 is 2. So that means the other angle, that looks like another 0. It should be a degree sign. There you go. So the other angle that goes from outside of this minute hand or this hour hand, or no, yeah, the hour hand, it goes all the way around, that's 270. That's the larger angle, but they want the smaller angle. Well, the smaller angle is the 90-degree right angle. So it couldn't be 45. 45 would be half of 90. It couldn't be 180 because 180 is just a straight line. That would be half the circle. And it can't be 360 because that's the entire circle. You get 360 if you start at one point and go all the way around. That's 360 degrees. So the larger angle is 270 degrees, and the smaller angle is 90 degrees. Now the third one was asking for the best estimate, and this one was difficult. Um, so what I found was I took the shape or the angles that they gave me, and I figured out, well, let me draw another straight perpendicular line so I can make my 90-degree angle. Because if I know what 90 degrees looks like, I can compare the other angles to that one. So I took my black marker and I drew a black perpendicular line to intersect with this one right here. Because I know that's 90. Now the angle that we started with went from here to here, right? So let me see if I can reproduce that. It goes from here to there. So that goes beyond 90. So I know that my angle has to be more than 90. If it's more than 90, it can't be 60. So I crossed out 60. And then I drew another, I extended this line. I went from here all the way to here because I know a straight line is 180. And I noticed that it didn't go beyond 180. So that means it couldn't be choice D because choice D would be 210. That would go past 180. So I didn't go there. And then I noticed that if I have to choose between 105 degrees and 150, well, if I have a 90-degree angle up to this point, if I add 15 more degrees, it's really not adding too much. So I drew an angle that I estimated to be 15 degrees. Because 90 plus 15 is 105, right? 90 plus 15 is 105. That's 105. That's 105 degrees right there. If I add 90 plus 60, that's 150. So that's what I think this is. I think this angle goes 90 degrees plus 60 more. So I'm going to say that this green angle, or the one that I copied in green, would be 60 degrees. Yeah, so from here to here, that's 60 degrees. 90 and 60 will give me 150 degrees. This one was asking if we have the hands of a clock that form 150-degree angle, what time could it be? So what I did was, first thing I did was I split the circle in half. I drew a 6 o'clock. So hour hand on the 6 and minute hand on the 12. And if I cut a circle in half, that's 180 degrees. Then I drew a perpendicular line intersecting that one so I could cut my 180 degrees into two 90-degree angles. So I know I'm looking for 150 degrees. So I have 90. Here's 90 where it's 3 o'clock. Every hour, if you notice, 90 degrees will contain 1, 2, 3 hours. So if I divide 90 by 3, that equals 30. That means every hour equals 30 degrees. So if I go from 90, if I start at 90, which is 3 o'clock, if I add another 30 degrees, that's 4 o'clock. But another 30 degrees only gets me 120. So what I needed to add 30 more. If I add 30 more to 120, I get 150. So I went from 3 o'clock to 4 o'clock, that's 120. 4 o'clock to 5 o'clock, well, now I have 90, 30, and 30. So that is 150 degrees. So that's where I got 5 o'clock right there. So 4 o'clock would only be 120 degrees. 9 o'clock would be 270 degrees, because that would be it would go 90, 90, and then another 90. And 10 o'clock would be 300 degrees, because that'd be another 30. So it can only be 5 o'clock. And let's see, this next one was quite simple. Out of the choices from the drop-down menu, they want to know what is formed when two rays share an endpoint. Well, I have two rays and they're connected by an endpoint, and what we do is we create an angle, right? It's not a straight line, it's not a segment, it's an angle. So this right here is called an angle. So you want to choose angle from the old drop-down menu right there. And the last one was a bit challenging. They wanted us to find the measure of an angle that's 3/6 of a circle. So if you start over here on the right, I took my circle and I cut it into 6 parts, 6 equal parts. And I know that for every hour, it's 30 degrees. So if I cut it into 6, each sixth or each part has 2 whole hours. So 2 whole hours would be 60 degrees. It'd be 30 plus 30. So I have 60, and then another 6. The second one would be 60. That's 120. And then my third 6, or my third out of 6, my 3/6, I go 60 plus 60 plus 60 is 180. And then I wanted to show you another way. I took another one and I just cut the whole circle in half, because I realized that 3 out of 6 is the same thing as 1/2, because 3 is half of 6, so that's 1/2. If I have 1/2, if I cut the circle into a straight line, that's 180, because a straight line or straight angle is 180 degrees. Or you could draw a perpendicular line to represent two right angles. And I know a right angle is 90 degrees, and another one would be another 90 degrees. So 90 plus 90 is 180. So 3/6 of a circle would be 180 degrees. Okay, so let me know if you have any questions about any of these. I'll try to get the unit practice up, and I'm going to try to provide as many resources as I can. And the message boards dealing with lines, rays, angles, angle measures, and things like that to help out. All right, thank you, everybody.